Welcome to Group 2's presentation of reaction time and agility. Our first test measured reaction time. In order to compare reaction times, we used two different tests, the first of which a ruler test, the second of which a color test. The third test we did tested agility, the power to move quickly and easily. The test we used was a quadrant test.
Procedures. The first pre-established test we did was a ruler test. The procedure for this test was an assistant held a ruler between the participant's finger and thumb of their dominant hand so that the top of the participant's thumb is level with the zero. The assistant then instructed the participant to catch the ruler as soon as they dropped it. The measurement recorded was from the bottom of the hand to the top of the ruler. This test was repeated 2 more times. These instructions were adopted from Brian Mack Sports Coach website.
Test 2 is the color test, administered to participants to test their reaction time. We developed this test in order to test the mental and physical aspects of reaction time. In order to conduct this test, we had one person holding the colored papers behind their back, while mixing them up to ensure random selection with each participant, while the other assistant timed the reaction time by beginning the stopwatch when the color was revealed and stopping it upon selection of the correct color. Due to simplicity, this test was easy to administer and record results.
Our other pre-established test was a quadrant test. This 3x3 box was made with masking tape and split into 4 quadrants. Numbers 1, 2, 3, and 4 were marked on each square. The subject was asked to jump from 1 to 2 to 3 to 4 as many times as possible in 10 seconds. A cycle was counted as complete upon return to quadrant 1. A quadrant was considered missed if the participant stepped on the tape. 23 participants were tested twice. These instructions were provided by a peer-reviewed study entitled The Study of Flexibility, Agility, and Reaction Time in Handball Players. For demonstration purposes, this is done on the board, but is always performed on the floor.
An error could have occurred during our first test, the ruler test. Due to familiarity, participants could have become trained to instantaneously and unskillfully grab the ruler faster, thereby improving the reaction time. This could have been avoided by giving breaks between trials.
Another error could have occurred during the color test. The participants could have seen the color behind the tester's back prior to reveal. To avoid this, we could have placed the presenter behind a barrier to limit the chances of the participant seeing the color, thus improving reaction time incorrectly.
An unexpected error during the quadrant test could have been that prior testing done by other groups on the same day affected the participant's agility. For example, if a participant from the Dizzy Bat test came to do the quad jump, their ability to jump from square to square may have been skewed. To avoid this, we could have done testing on a separate day than other tests.
For test 3, the quad test, there were 24 people tested and data was collected. The mean of the results was 5.34 cycles, the mode was 6 cycles, and the medium was 5.69 cycles. For the same test, we developed a frequency distribution. We split the scores into 7 groups ranging from 1 to 1.9, 2 to 2.99, and so on. The most repeated score was 6 to 6.99 with a repetition of 8. The least occurring score was 2 to 2.99, representing 0 participants.
To calculate z-score, we used the data collection from the ruler test. The score closest to the mean was completed by a participant with an average score of 6.33. Their z-score was negative 0.01, meaning they were close to 1/100th standard deviations away from the mean. The highest z-score calculated was achieved by a participant who had an average score of 11.67. Their z-score was 2.01, meaning they were over 2 standard deviations from the mean.
To calculate t-scores, we use the data from the color test. The closer to 50 the person is, the closer the participant is to the mean. The individual who scored the closest to the mean scored an average of 0.4275. Their t-score was 50.22. The person who scored the farthest away from the mean had an average score of 0.72 and a t-score of 23.41.
For Pearson correlation, we calculated the relationship between the ruler test and the color test. We achieved a Pearson correlation score of 0.199. Due to this falling below 0.20, this correlation is low. One possible reason for a small relationship could have been that 2 different measurements were used for each test. In the ruler test, we used inches, and in the color test, we used seconds. This could have been avoided if we chose 2 tests with similar measurement techniques.
To visually display this data, we developed a bar graph comparing the difference of the means. As you can see, the 2 means were very different. As mentioned earlier, this is due to 2 different measurement techniques being used.
The linear regression calculated from this correlation is shown. The direction of this correlation was positive. The critical value of this test was 0.381. Because our R value that was calculated fell below this, there is a significant difference between the scores of the two tests. The correlation is displayed on the scatter plot.
Another way to calculate correlation is to use a Spearman-Rho equation. This equation is used when one or more groups in the dataset are arranged in ordinal or rankings measurements. To find this, we took the average scores from the color test and the ruler test and ranked each score 1 to 24. We then correlated the scores with the ID number of the participant and found the difference between their rankings on both tests. After squaring the difference, finding the sum of the squares, and using the Spearman-Rho equation, we found that we had an R prime value of negative 0.092. This is considered a very weak correlation, which matches the findings we found from the Pearson correlation. To calculate a meaningful t-test, we used trials 1 and 2 from the quadrant test. The result was a t-test of negative 0.14. The critical value obtained from the t-table was 2.069. Because our t-score after running the t-test was within the critical value range, it was determined that there is no significant difference between trials.
To test validity quantitatively, we found the validity coefficient of the color test. In order to develop a 2x2 contingency table to displace our data, we split our group into two groups, trained and untrained. Prior to the test, we determined the person mastered the color test if they scored below a 0.4. We chose this reaction time after reading the article, Speed of Processing in the Human Visual System. A person was qualified as trained if they claimed to exercise 10 or more hours weekly. After splitting the groups, we found that 5 of the 8 trained individuals meet the master standards and 10 out of the 16 untrained individuals were classified as non-masters. This led to us having a validity coefficient of 0.62. The closer this coefficient is to 1, the more valid, and the closer it is to 0, the less valid the test is. Because our score is closer to 1 than 0, we consider this to be a valid test.
For our test on validity, we developed a pie chart. This allowed us to see our expectations being met and that our test was considered valid. The purple represents the untrained non-master, the largest section of the pie chart. The blue represents the trained master, which in comparison to the red, trained non-master, is larger. To test validity qualitatively, we took the test ourselves to see if there were any areas of weakness or confusion. This is called content-related validity. After taking the test, we determined that the main purpose of our quadrant test was to test the agility of the participant. All areas of important content are present.
To test reliability quantitatively, we used the Kappa formula. After doing this, we determined that if a person completed 5 squares, they were classified as a master. We chose 5 after reading through the research article discussed earlier in the video. After performing a Kappa reliability test, we determined that our reliability was a 0.72. Because this is close to 1, we can determine that our test is reliable. We present this data in a pie chart to visually display the reliability.
We also presented the same data in a scatter plot. The scatter plot allows for one to see the relationship between trial 1 and 2 of the quad test that were very much related. They had a positive correlation.
In order to ensure reliability, we used intra-rater reliability. This means that we had the same person scoring the test for each person in each of their trials. This is how we qualitatively ensured reliability.
After completing each of the tests, there were many things we noticed. As discussed earlier, we noticed many errors that if we redid this experiment again, we would correct in hopes of improving the data.
Overall, we found that our 2 tests on reaction time were not considered to be related. The Pearson correlation was too low and considered not strong. Our 3rd test, which had 2 trials, was considered to be very related. Our Pearson correlation was 0.81, which is considered a strong correlation.
We hope you enjoyed our video. We hope the information that is contained within it helps you in your further research and future educational endeavors.